In this demo, we'll learn how to calculate eigenvalues and eigenvector. Let's first import the required libraries, NumPy and SciPy linear algebra. Next, we'll create a test dataset from a rating system on a scale of 1 to 10 in the form of NumPy array. This forms a square matrix of which we will calculate eigenvalues and eigenvectors. We'll use EIG function of linear algebra subpackage to calculate them. Let's pass the test dataset, test rating data, in the EIG function. Then, assign eigenvalues to first and second eigenvalues objects and print them. Let's apply the slicing technique and print the first eigenvectors by using :0 for the first eigenvector. Apply the slicing technique and print the second eigenvector using :1. The output is displayed here. Let's now understand the statistics package. This package contains many useful distributions for which you need to generate random variables. You can also get the theoretical properties for these variables. Random variables are used to specify the finite set of values that build statistical hypotheses, determine probability, and predict the outcome. The statistical package also offers convenience methods that are used widely in the world of statistics. Statistical functions, such as linear regression, is another function to determine the relationship among variables that are linear in nature. It's used to determine dependency to identify whether a change in one variable impacts the other. The function normal test is used to validate and test the hypotheses built during data processing. The syntax for these functions are displayed on the screen. Let's now take a look at one of the distributions. Cumulative distribution function, or CDF, provides the cumulative property associated with a function. Take a look at the cumulative frequency table. The frequency is the number of times a particular number or event takes place. It's the total counts up to a certain number. On the screen, age that ranges from 0 to 10 has a frequency of 19. The cumulative frequency for age range of 21 to 30 is 97, which signifies the total number of persons up to that age, which is 30. The cumulative distribution function provides the cumulative value from negative infinity up to a random variable x, and is defined by the notation shown here. Probability density function, or PDF, of a continuous random variable is the derivative of its cumulative distribution function, or CDF. Probability density function for a random distribution helps describe the probability that for any given continuous random variable, its value lies within the same interval. To understand it better, let's say that f by x is the continuous distribution function for a continuous random variable x. The probability density function, or PDF, for x is given by f times x is equal to df times x divided by dx, which is the derivative of CDF. Let's understand the statistics subpackage of SciPy with the help of an example. Here, we'll use functions for normal distribution. It's a statistical way to find the real values of random variables whose distributions are unknown. Both CDF and PDF accept loc and scale as arguments to adjust the location and scale of the data distribution. For example, standard normal distribution location is the mean, and scale is the standard deviation. First, import norm for normal distribution. Let's use RVS for random variables. Here, the location is 0, scale is 1, and the total size is 10 random variables. The output will return the values for the random variables. Next, apply CDF for cumulative distribution function. This helps describe the probability that for any 10 continuous random variables, the values of the variables are less than or equal to the argument of the function. Here, the total size chosen for the variables is 5, for location is 1, and for scale is 2. The output returns the result of the function. Then, to compute the probability density function for random variables, apply norm PDF. Here, the total size of the variables is 9, location is 0, and scale is 1. The output displays the result of this function. Let's go to the Weave package. Note that the Weave package will be taken out of SciPy, and it will be a standalone package in the upcoming version of Python. The Weave package provides tools to include C and C++ code within Python code. This offers an easy way to modify and extend any supported extension libraries, such as WXPython. It has built-in C and C++ code within Python and results in speeds up to 1.5 times to 30 times over algorithms written in pure Python. There are two ways of using the Weave package. The Weave inline function executes C code directly within Python, whereas Weave Blitz translates Python NumPy expressions to C++ for faster execution. The next package that is widely used in SciPy is the I/O, or input-output package. The I/O package offers a set of functions to deal with several kinds of file formats that include MATLAB files, IDL files, matrix market files, wave sound files, ARFF files, and netcdf files. The most commonly used files are MATLAB files, ARFF files for Weka or Waikato Environment for Knowledge Analysis, and WAV files. This package provides some additional files, including load text files, clever loading of text or CSV file, and NumPy-specific binary format files. The method applied for these file types are shown on the screen. First, let's import the libraries required, NumPy and SciPy linear algebra. Next, we can formulate two linear equations for the given scenario. X plus y equals 30, where x is the number of true or false questions and y is the number of multiple choice questions. The second equation is 4x plus 9y equals 150, as a true or false question carries 4 marks and a multiple choice question carries 9 marks. Let's create two NumPy arrays, one for the variables and another for values. Let's use the linear algebra solve method to solve the linear equations. Here, we can see the value of x, or true or false questions, is 24, and value of y, or multiple choice questions, is 6.